So basically, as a part of tinkering with technology, recently I am tinkering with the ROS2 to learn how I can integrate AI with robotics, the CODA stuff and all. So basically, when I started with ROS, it is like quite overwhelming for me, and this is not because uh, the ideas are very hard. It is because that you are shown lot of commands, and even before we understand how it works and what does it mean. So in this video, I am trying to go the opposite way. We will run as little as commands as possible and focus on what is happening behind. And by the end of this video, I think you will have a brief idea or about publishers, subscribers, Turtlesim, and why real robots also work in the same way. And you will be also be introduced to GUI using Gazebo as well. So this will be an interesting video for everyone else. Yeah. So here is the only idea that you need at the start. Our ROS is not function calling. It's not object talking to each other. ROS is data flowing through named channels. Some programs write data. Some programs react to the data. Everything else is built on top of that. So basically, we have few channels, we have few nodes. So these nodes will subscribe some messages to these channels, and these channels listeners will also subscribe to this channel, and this publisher can talk to the subscribers. Basically, that's the basic concept that we have for ROS communication. And here we have the discussion regarding the subscribers and publishers in the ROS2. And we are not going to learn those commands by heart or anything. So basically, I have set up a Docker for running this ROS, and I will source the ROS environment, and the program called demo node cpp that is provided will provide you with two things. One is an Docker which sends the text messages once per second on a topic called chatter. That's the key point. The Docker has no idea who receives the message. It does not check, it doesn't care, it just publishes. And that's what the publishers usually do. It does what a publisher usually does. It just subscribe or send the messages to a channel. And another side of this particular channel, we have what we call as the subscriber. This program actually listens to the same channel or same topic called chatter, and whenever a new data appears, it reacts. And this is where things get really important. The listener also does not know where this messages comes from and who sent this data. No direct connection is happening, no dependency. The data just comes into the publisher, and the subscribers picks it up. And you can see the number of topics who all are using this channel by using the command ROS2 topic list. You don't need to run this or anything. You don't need to by heart this as well. It just makes you understand what is happening under the hood. So ROS keeps a live map of data channels. Topic appears when the data flows. They disappears when nothing is using them. This is how usually how ROS2 plays flexible. Once you have the subscribers and publishers up, you can see who all are using this channel. You can also debug this, and you also check the chatter channel using a command called ROS2 topic echo chatter to see how the code is doing, what is moving through the system. So that basically summarizes what publishers and subscribers do. And once these publishers and subscribers are up and running, we can move on to the Turtlesim. So here the idea is same. Only thing is that now you have an UI where everything can be visible. And for this, we had to get the Gazebo up and running in your system. And you can just use the command ROS to run. You can also install Turtlesim related installations in the command. And you can use ROS2 run Turtlesim node to make this up and running. So Turtlesim is just another node in ROS2. It opens up a window with a GUI, and it listens to the velocity commands. So for velocity commands, we use the command teleop key. So this is a publisher for us, and the ROS2 node or the Turtlesim node is the listener here. And this keyboard program is a publisher. When I press the key, you are not driving a turtle, you are just publishing the velocity data. And this is being reflected in your subscriber while you press the key. And the commands usually goes through the topic called CMD well. It carries the velocity messages, and if something publishes to it and something subscribes to it, the motion happens, and that's the entire loop. That is basically like you press the key, that message is pushed to the CMD well, and the ROS node or the turtle node, which is listening to that particular channel, will take that particular message, and the velocity will also change according to the message that you give to it. So that's the entire loop which runs the board for us. So even in the real world, the idea doesn't change much, because we have sensors, we have the motors. So basically these sensors will get the values, and it will publish the messages to be run. And the motors usually subscribe to these particular channels and take the velocity. And it's just that we have a hardware on top of the messages, on top of the software that we, or the simulation that we just did right now. So it's the same message flow that we follow even on the hardware. That's why this Turtlesim simulation is like a hello world in the world of robotics. So why this is very crucial, and why does this scale? So basically, as I said, ROS2 just connects the how the velocity is subscribed and published and subscribed between the nodes. So these publishers and subscribers can be anything. It could be hardware, even an AI algorithm that decides, okay, what is in front of it, what action to be taken. So this AI will publish the messages, uh, or the camera can publish the screen, and the AI can subscribe to the camera images, and it can further navigate the paths based on the output it has. So it could be like camera publishes the images, AI model subscribe, and navigation publishes the paths, controllers subscribe. By then these big systems are not that complicated when you think about in the sense of publishers and subscribers and topics, of course. So basically the thing is that whatever values that you wanted to decide on, those values are being published, and the nodes that need to take the action will be the subscribers. That's the basic concept that I can guess as of now. So if you are if ROS finally feels slightly better, that was the whole point of this video. I don't think we need to chase these commands over and again. Yeah, I think we should be more aware of the how the data flows, and even I am learning on the go of what I see in the ROS. So basically, I believe by end of couple of iteration of this procedure, I think even me as well as you will be learning more into the ROS, and I'll be exploring more stuffs like NVIDIA, CODA, ROS, AI, LLM training, pre-training, fine-tuning, optimization, LangChain, chain, LAN graph. So if you're really interested in technical stuff as well as other areas where we do projects or things where I think I am improving on myself daily, and if I think that could be useful for everybody who is watching this video, and if you want to stay on what I do for do again next in my next what I do next, I think you should really like this video and subscribe to the channel. Bye.